Jackie. Okay. You have a horizontal tangent line, and the graph is concave up. What has to be true? A horizontal tangent line and the graph is concave up at the same time. Relative minimum. F has a relative minimum. Relative minimum. This is another way to show relative minimum. That you have a horizontal tangent line and at the same time, your second derivative is positive. Now, what if your second derivative is negative? F is concave down. What does that mean? Horizontal tangent line, graph is concave down. Relative max, right? The smooth kind, not the sharp kind. You have a relative max. Relative max. Your last option is, what if the second derivative is equal to 0, meaning it's not positive, it's not negative, it's not concave up, it's not concave down. If that happens, the test fails. Use another test. Everybody okay? We now have 3 ways to show that you have a relative max. Hey, Mr. Madsen. You are always welcome, though. Okay, so 3 ways to show they have a relative maximum. The function changes. What's the change again? For relative max. At the function.
From increasing to decreasing.
Relative max, the function changes from increasing to decreasing. That's one way. Second way?
The f prime changes from positive to negative.
F prime changes from positive to negative. The third way, the new way, relative max.
And the f double prime is
Shh, I love that. There's like Evelyn and Eric and Jesus who are sitting back there waiting for you to do all the heavy work. We said relative max, F changes increasing to decreasing. Or F prime changes from positive to negative. Or the second derivative test, the 2 things that have to be true. The second derivative, what's true about the second derivative? For a relative max. This is where you guys are going to get it wrong. The graph has to be concave down, so what's true about the second derivative? Second derivative is negative. Second derivative is negative, and you have a horizontal tangent line. It has to be both. Are we okay? Now here's the thing. The second derivative test only works for relative max and min. Not absolute max and min, just relative max. Everybody good?
Yeah.
All right, I want to see what you can do with this next application problem. All right, this is tough. This one, if we're lucky, we're going to get finished before class is over. For real. Okay, so what I want you to do, go through, read through this. Think, what would you do if this was on tonight's homework, tomorrow's quiz? Read through this, mark it up, figure it out. We'll talk in a bit.
The margins at the top.
I can do the first 6 weeks out every week.
Stay focused.
Every tangent page contains this. The margin of page. At the bottom, you on the margins, yes or
You should be reading through this, looking for your constraint, looking for your optimization equation. Sorry. Praying that you're going to find your endpoints.
This is the entire deep.
The outside of the
Yeah, for
I feel like it's L minus 1 and then W minus 1.5, right? No, it'll be L minus 2.
Ashley, how you doing there?
L minus 2 times.
This is my idea. That's my idea.
So I'm looking for your constraint, your optimization equation, and I'm looking for endpoints. No. Okay, I'm amazed no one is actually bothering to look at the diagram that I so carefully created for you with love. No one's actually using the variables that are there. Everyone's using like L and W. Nope.
So, 44 square inches is X times what?
X times Y, because the 24 inches is 1. Where are you?
Finishing early really isn't anything. Are we supposed to just
All right, friends, let's pull it together. Part of what makes this problem a little bit challenging is you've got, well, I gave you the variables. That was supposed to be the kind part. Don't expect me to always give you the variables. But this is where the print is. What's the constraint?
The margin.
That's not the constraint. What the constraint? What do you have to make sure you do? You need 24 square inches of print. So the constraint is that you need 24 square inches in here. Has to be 24 square inches. Now, what are some examples that would give me 24 square inches? I could do, what, 1 inch wide times 24 inches tall. That's a way. What else?
2 inches wide,
2 inches wide,
12 inches.
12 inches tall. What else?
But isn't it like, I'm trying to find a relative time.
4 inches wide, 6 inches tall.
What would it be, 0 or 24?
You guys are really good with your multiplication facts, and everyone's sticking to nice, kind numbers. Hold on, Jackie. Could I do the print area where it's only half an inch wide?
Yeah.
Could I get 24 square inches if I only have a half inch wide?
Yes.
What would it be?
48.
48, okay? Could I go even less than half an inch?
Yeah.
Like what?
Well, 25.
A fourth of an inch, a tenth of an inch, a hundredth of an inch.
0.
It would be, now, I heard 0.
0 to 24.
Could I go 0?
No.
Why not, Jose?
Because everything that we multiply here is 0.
Right, if you say let the length be 0, how tall does it have to be to get an area of 24? You'll never get it, Jackie.
But aren't we, isn't it the same as like finding the relative max?
Okay, and here's what last class got all turned around. So let me get you guys caught up. So everybody's good. We have to have 24 square inches.
Yeah.
Have to be 24 square inches. How long is this piece?
We don't know.
How long is this piece? I labeled it for you. How long is this piece?
Y.
Y. How long is this piece?
X.
X. What's the constraint?
24.
What's the constraint? The constraint just means what has to be true.
X, Y equals 24.
X times Y is equal to 24. I heard Y times X equals 24. Same thing. What am I trying to optimize? Go back and read the question. What are we trying to optimize?
The least amount.
You want the least amount of paper. Well, what's the area of the paper that I'm going to use? That's this guy here. Right? I've got those boundaries. I've got those margins where you're not supposed to type. I've got to figure out how long this is and how long this piece is. How long is this piece? Not too wide. Look at the diagram again.
2 inches.
Y is however long it is in the middle. An inch and an inch on either side. So this has to be Y plus 2. How tall?
Well, X plus 3.
Right. I've got it. What is it? An inch and a half down here,
Yeah.
and an inch and a half down up here. So X plus 3. Y plus 2 times X plus 3. What I'm trying to optimize is, I'll just call it P for paper. is y plus 2 times x plus 3. That's my constraint, and that's the optimization. And that is part of the hard stuff when it comes to optimization. It's taking the words and the geometry and bringing the math in. Are all the friends mostly okay?
Yeah.
Okay, now, so what are we going to do next?
Find the derivative.
You want to find the derivative. You want to find the candidates. Anybody see a problem with doing this?
Yes.
Yeah.
The variables.
Two variables.
You want to rewrite?
Jesus, what's your plan here? You get two variables. We don't know yet how to find the derivative when there's two variables. So come back after Thanksgiving. I'll teach you. What's your plan? Beto's got a plan. Jesus, what's your plan? How do you get rid of this issue of two variables here? Okay, but where? You need to go back to this constraint, right? The constraint is the relationship that says if x times y is equal to 24. Well, that's the same thing as saying what y equals 24 divided by x. Same thing. So the amount of paper is going to be 24 divided by x plus 2 times x plus 3. That's what you're trying to optimize. Good news, now that you have one variable, you know exactly what to do. You have the skills to do this. What are we going to do?
You distribute the
Product rule.
Okay, some people are saying product rule. We could do the product rule to find the derivative. Absolutely, product rule works. Your other option?
distribute.
You could distribute and then take a derivative. It does not matter to me which one you're going to do, but you're going to find the derivative. After you find the derivative, set the derivative equal to 0 and solve. Figure out where the derivative does not exist, and then we start having conversations about candidates and all the things. Everybody good? Okay, take 2 or 3 minutes, finish this off. And then I'm going to rock your socks.
I don't know. No, it's the derivative and this one is the derivative of this one. What would be the derivative of 24x plus 2?
I like challenges.
Yeah, he divides x.
Yes.
Y equals
What would be the derivative?
since y equals
Negative 28 because you could rewrite this if you wanted to as 24x to the negative 1 power, and then the power will just bring the power down. Alright, so see, some folks are multiplying things out. I'm going to multiply it out.
That's with the 2, right? Or is it plus 2?
So 24 divided by x plus 2, x plus 3, x times 24 over x is 24, 2x, 72 over x is 6. If you do the algebra first, that's what you're going to get. And then you're going to have to find the derivative. And I would hope most of this is pretty easy. 72 over x, everybody needs to know what the derivative of that is. Because I distributed.
Negative 72 over x squared.
It's going to be negative 72 over x squared. Nice. Now, for those of you that are like, what just happened there? Way back in the day, I told you guys, like, derivative of 1 over x, we're going to do it again and again and again. Derivative of 1 over x, if you didn't remember it, you'd rewrite 1 over x as x to the negative 1, and bring the power down, reduce the power by 1. So negative 72 over x squared, plus derivative of 2x, 2, plus the derivative of 30. 0. Great. Now you've got two thoughts here. P prime is equal to 0, and P prime doesn't exist. If negative 72 over x squared plus 2 is equal to 0, where does that happen? And over here, is there a place where negative 72 divided by x squared plus 2 doesn't exist? Where doesn't P prime exist?
Here.
X equals 0 is going to be a problem. How about this guy? Negative 72 divided by x squared plus 2 is equal to 0. Maybe you want to subtract 2 to the other side. Maybe you want to do a little cross multiplying. Lots and lots of options. I am still fraction killer. I'm going to multiply by that common denominator, x squared times negative 72 over x squared, negative 72. X squared times 2, 2x squared is equal to 0. Oh my god, everybody can solve this equation instead.
Yeah.
So what is that? 2x squared equals 72. X squared is equal to 36. So x is 6. Or negative 6. How many candidates?
One. We don't know.
How many candidates?
One. You can't have a negative.
Yeah, one negative.
Because it can't be negative.
So I see 3.
Oh, one.
Nobody seems to like the idea of 3 candidates here. No one's going for that. I heard either 1 candidate or 2 candidates.
What?
Okay, what candidate are we going to get rid of?
Negative
Negative
6.
Negative 6 makes no sense. No sense. Because we're talking about how tall this is. Makes no sense to go with x equals negative 6. Good. Ashley?
As I said, we couldn't do 0.
And you can't do 0. Why?
What? No, I'm asking.
No, I ask the questions here. I get paid to do this. X equals 0. Why can't I have x equals 0, Ashley?
You know how yesterday.
Oh, again with you asking the questions. We're having a power struggle.
You know how we did the garden and we used 0?
Yes.
Okay, why can't we use it here?
Okay, Jackie, can you tell her why?
I was gonna tell you because the other 2 candidates are gonna come from the endpoints that we're using, right?
That's not the issue. That's not the issue. What, the issue that Ashley's asking, why can't I use 0 here?
Because if you multiply it times a number, it's gonna be 0.
What's the constraint?
24.
I need 24 square inches of print. If you tell me, hey, I'm going to make the paper for you, and you know how tall it's going to be here? 0 inches. I'm like, girl, how am I going to put 24 square inches there? I have, sorry. I spent too much time with my 9-year-old. If x is 0, I can't possibly get 24 square inches. This guy doesn't work.
Wait, so then how did we do the garden?
That was different.
It's still constructed 32 yards.
We'll talk about the garden in a little bit. Is everybody else mostly okay?
Yeah.
Okay. Same process as before. Find the constraint, find the optimization, find the derivative. Where's the derivative equals 0? Where's the derivative does not exist? Great. Everything's the same. Oh my God, you guys know exactly what to do. How are we going to finish it off?
And evaluate
Evaluate the amount of paper. Where?
at your endpoint.
Evaluate the amount of paper. Where?
At y plus 2 at x 3.
At your candidate. And where else? At the endpoints. And
But what are the
here
endpoints?
is where your world falls apart. What are the endpoints?
Not 0.
Your paper is a function of x. What's the smallest x value that you can use?
0 point
0,
something.
but not.
It's 0, but not equal to 0.
Ah, 0, but not actually 0. Whatever number is just a little bit bigger than 0 is the smallest.
Yeah.
What's the biggest?
24.
24?
Wait, no.
24, that says,
That's
okay,
12.
24 here and then 1 inch this way?
No, it's not equal.
What if I doubled the height to 48 inches?
Half inch.
Then I could do a half. What if I doubled that to 96? Then I could go with a fourth of an inch. What's the largest value for x I could possibly consider?
You confuse me. You confuse me.
Infinity. Guess what? We don't have endpoints.
So that
For the first time ever, we don't have endpoints. If we had endpoints, Caleb, love the question. What does that mean?
doesn't apply to it.
If you had endpoints, we would be done because you guys would evaluate the amount of paper at x equals 6, your candidate. You'd evaluate the amount of paper at the endpoints, and you'd say whichever one is biggest wins. Everybody's okay with this?
Yeah.
Somebody smack Eric. All these people, okay. All the friends are okay? Okay, so here's the other thing. And yeah, if you turn the camera. I want to come back to the second derivative test. This is going to catch you by surprise. I completely lost second period, which is why I'm trying to refill. I want to go back to the second derivative. I feel like for the most part, everybody's good with this stuff. Setting up the constraint and the optimization, a little tricky in the beginning. Once we do that, we're good. Okay, I want to look at the second derivative test. Second derivative test says, go find the second derivative. Go find p double prime. We're like 5 minutes away from being done with this problem. Go find p double prime. We know p prime.
4x.
Right, negative 72 over x squared. One option if you want to find the derivative. Quotient rule. Another option if you want to find the derivative. Right, Jackie? I've got a fraction, so I could use the quotient rule.
Oh, so that.
The other option is the kid that says, you know
I
what?
thought this was the derivative. Negative 72 plus 2.
Rewrite it as negative 72 times x to the negative 2. Your second derivative should be 144x to the negative 3.
Wow.
Plus the derivative of 2 is going to be 0. Okay, now for those of you that are like, wait, that's not what I was doing. How many guys were in the middle of quotient rule?
I wouldn't know.
So let's go back. Negative 72 over x squared. Quotient rule. How do we do it? Low.
No, D high.
D high. What's D high?
0.
0 minus high.
D low.
D low. All over.
No.
Low. Low. 2x times 0 is going to be 0. Negative of negative 72 times 2x is 144x. X squared squared. X to the 4th. You're going to get 144 over x cubed. That's the second derivative. I don't think anybody in the room was expecting that we were going to use the second derivative.
No.
What the second derivative tells you, though, is evaluate the second derivative at your candidate. And what do you know? If I plug 6 into the second derivative, we're getting 144 over 6 cubed. Now, those of you that know that 6 cubed is 216, nobody cares. Nobody cares. You're impressing no one. The only thing I care about is that my second derivative is positive. What does that tell you about your candidate? The graph is concave up, and there's a second thing. You have a horizontal tangent line. So I'd say something like this. Since p prime of 6 equals 0, and I want to emphasize the and here. P double prime of 6 is positive. P has a what? Horizontal tangent line, and I'm concave up. What does P have?
Relative minimum.
Should be relative minimum. Horizontal tangent line and concave up. Relative min. P has a relative min. Relative min at x equals 6. And now here's the problem. I know you're like, no, I'm done. I have no problem. Even my calculus BC year 2 kids at Northside, they think they're finished.
We're not?
You want to be. You wish you were. Some of you are like, no, I was finished back there.
We still don't know the dimensions, right?
We don't know the dimensions, but what is it that we're trying to do? Beto, what are we trying to do?
Find the least amount of paper that we use.
Beto just hit the nail right on the head. One more time.
Find the least amount of paper that we can use.
You want the least amount of paper. That word least means that what you want is an absolute minimum. What kind of minimum do we have? Relative minimum. The second derivative test can't tell you that this is the lowest point. All it can tell you is you have a relative minimum. We're okay? Okay, so stay with me on this. If you had sketched the graph of x versus the paper, and I think next year when I reteach this, we're going to actually stop and do that. What we know is that I can only consider values of x that are positive. And how many places is the derivative equal to 0?
One.
Just one. Somewhere out here at x equals 6, if I were to look at my graph at that special point, two things happen. You have a horizontal tangent line, and it's concave up. Is everybody okay with this?
Yeah.
Does anything else happen with the graph?
Not that we know of.
Does the graph maybe increase and then start to decrease?
Yeah, maybe.
Maybe.
I hear the maybes, I like the maybes. We know something that says that cannot happen. If the graph were to increase and then turn around,
Oh, it can't decrease.
Oh, cause it can, oh, it's positive infinity.
the graph would have to change from increasing to decreasing. The derivative would have to change from positive to negative. What would happen? You'd have another candidate. You'd have to have another place where either the derivative doesn't exist or the derivative is equal to 0.
Isn't it also because that's infinity?
Well, but it has to do with the fact that x equals 6 is the only time I can actually make a change. And so if I look at that graph, this is just my sketch to get the point across. What kind of minimum?
Absolute.
That's also the absolute minimum.
If that's all the graph is allowed to do,
That's also the absolute minimum.
That's also absolute.
everybody's okay with relative min, right?
Yeah.
If that's all my graph can do,
It's that.
That's absolute.
then this has to be the absolute minimum as well. Okay? So here's the write-up. Because P of x has only one relative extrema, and here's where we've got to be careful. For x greater than 0, because there is another extrema over here, out here at x equals -6, but that doesn't make any sense for our word problem. Because P of x has only one relative extrema for x greater than 0, this means that P of x has an absolute min at x equals 6. It's because you only have that one candidate, that one place where a change can happen. That's why it's a relative min and an absolute min. Nice job.
Are we
Well, okay, and thank you, Ashley. I thought we were done last class too. I was so excited. I'm like, ta-da, we did it. We're not done. Juan's done. Juan was done a while ago, I can tell. You gotta go back and answer the question. What are the dimensions? What are those dimensions? The dimensions are the length and the width. How long is the paper? How wide is the paper? Careful, Carlos, I hear all the things. Y plus 2 and x plus 3. I don't think we know what y is. But you know what x is. X is 6. So,
It's y4.
right? So that's going to be, what is that, 9 inches?
9, yes.
9 inches. And how long?
Why?
Is going to be y, but what's y?
24 minutes.
Y is 24 over x, so what's y? Y is not 2.
4.
Y is y4.
Because when you put in 6, you do that.
We knew that x is 6. Right, and they have to, I know Ashley, I'm sorry. I'm sorry. So the length of the paper is going to be 4 plus 2, which is 6 inches. Okay. Just between all of us,
Oh, you add, okay, yeah.
right, because basically we knew that x had to be 6 and y is equal to 4. I just want to be really clear. I am not going to put a question like this on a test or on a quiz. No, x is 6.
Yeah.
So 6 plus 3.
But the length, so the answer would be 8.
Y is 24 divided by 6, that's 4. So 4 plus 2 is
Yes.
6. Okay, so before Kaylin asks me another question, I have no intention of putting a question like this on a quiz or on a test. It has taken us 35 minutes to go through this question together. That was just, that would be mean, but man, calculus is beautiful stuff. If it hadn't been for Hurricane Harvey, we'd have another 3 days of optimization that we'd be working on. Instead, what you guys have is the next 7 minutes to get started on the homework, which is kind optimization questions, like last night, and you have the solutions. It's assignment 57 in the back. On what page? Oh, 69. Man, what a day. We talked about length and width. There were all sorts of inappropriate teenage boy jokes about how long it was, and they think I didn't hear it. Especially when it went to 9 inches, they were like, whoa. And now we get an assignment on page 69, the sexual energy. It's hot in here.
Mister, do you want me to cut it out?
Yeah, we're gonna cut it out. I'll probably edit out the last 30 seconds.